Good evening. Today we will go for the design of the doubly reinforced section. Now in design, we have design of the beam that is for balance section, because balance section is the most economical section. So design always we have to go as balance section. And so here we do not have any trial. Directly we have to consider value of Ku that is equal to Ku max and value of Xu that is equal to Xu max. And therefore this design for doubly reinforced is rather much easier compared with analysis of doubly reinforced section. So now we will go with the problem. Now you can see this. We have a doubly reinforced section, and that we have beam of rectangular section is 300 mm by 600 mm. It is subjected to UDL. Now it is not given factoried UDL, only working UDL is given, or simply supported span of 6 meter. Calculate the amount of steel. So amount of steel means we have to design this section. Amount of steel and use M20 and Fe415. So effective cover is given 50 millimeters. So what is given data? So we have given data B 300 millimeters, D 550 millimeter, FCK we have 20 Newton per mm square, Fy 415 Newton per mm square. Now we will plot this simply supported beam 45 kilonewton per meter, 6 meter. So we have taken W working, and then we will make the moment as factorial. So now we are going to get bending moment as we know, simply supported we have WL square by 8, 40 by into 6 square by 8, 202.5 kilonewton per meter, kilonewton meter. This is working moment. Now what will be ultimate? We have to multiply it by 1.5, and that will gives us ultimate moment as 303.75 kilonewton meter. Now we will start with, we have to go for design, and here you can see we have to design it as balance section. Balance section means we have singly reinforced, that will be mu limit, and then for remaining we have to go for compression steel. So now we will go with moment of resistance. We have mu1 plus mu2. Now as it is balanced, so mu1 becomes your mu limit plus mu2. So now mu we know, which is 303.75. Mu limit we will calculate, from which we will find value of mu2. So now you can see mu limit Ru max into Bd square, and we know value of Ku max. So we have that is 0.48. So if we will go to page number 71, then you will get values for Fe 250. Value of Ku max is 250. Value of Ku max is 0.53. If we will go for 415, it is 0.48, and if we will go for 500, then it is 0.46. So we have these values. So you can directly give reference of this and take Ku max value, which is 0.48 as per IS code. So now second formula also we have seen, that is 700 divided by 1100 plus 0.87 Fy. So you can go by any formula, we should know, because in competitive examination you may come across formulas also. In that case you should be in position to correct the answer. Then we have from this Ru max. Now Ru max we know 0.36 FCK, Ku max 1 minus 0.42 Ku max. Now we will substitute the value FCK we know, Ku max we know. We will substitute these values, which will gives me Ru max value, and then from this we will get value of Ru max, and that is equal to 2.76 MPa. So this is value of Ru max, which is 2.76 MPa. Now here we have just substituted the values 0.36, 20, 0.48, 1 minus 0.42 into 0.48, and which will give me value of 2.76, that is Newton per mm square. And by using this we can find value of mu limit. So we will calculate mu limit, which is Ru max into Bd square, and that will gives me 2.76, 300 into 550 square, 250.47 Newton mm. So that is 250.47 kilonewton meter. Now mu2 we have mu minus mu limit. Now mu we know 303.75 minus mu limit we have calculated 250.47. So this will gives me 53.28. Now we have to find AST1, AST2. For this mu limit value we will get as AST max, which we will say here as AST1. For mu2 we will calculate value which we will use me value of AST2. Now already we are with this formula when we are with theory part. In that theory part we have calculated these values because AST1. So just also in last video, if you remember, we are going to be with Cu is equal to Tu and we have 0.36 FCK Xu into B. Now it becomes Xu max into B, that is equal to 0.87 Fy. Now I will mention it as AST1. And from this you can see we have AST1 that is equal to. Now this is mu limit. And whatever this value you will have, this is Cu. And if you multiply it by T lever arm, then you will get it as mu. So mu equal to you will get mu we will get it as 0.87 Fy in bracket D minus 0.42 Xu max. And from this we will get value that is equal to into AST1. And now AST1 we will get mu upon 0.87 Fy divided by D minus 0.42. This now I can write it as better max because we are going to be with mu limit. And now if we will substitute the values in this equation, so by substituting values, we are going to get value that is of AST1 and we have this value 1579.81 millimeter square. Now we know value of mu2. Now for mu2, we have to go for now mu2 we can find 0.87 Fy AST2 and for this we have lever arm as D minus DC. So AST2 we will get it as you can see 0.87 Fy in bracket D minus Du or this is DC. And now we will substitute the values in this equation. And by substituting value in this equation, we will get value of AST. Now AST we will have AST1 plus AST2. And then from this we will get this value as 1874.95 mm square. Now you can see if we will go 314, that we are going to be with 25 mm. So we have 20 millimeters. And for 20 millimeter diameter, we have area that is 314.15 millimeter square. And then we have 1874. So 3 into 6 if we will go for, then we are going to get it as 1884.90 and which are greater than this. So we can provide here 6 bars of 20 torr. Such you have to calculate it and you have to decide the number of bars. Now we have to go for ASC. Now how we will find for ASC? So now we will have this as equal to neglecting FCC, FSC into ASC into D minus DC. Now we are interested to calculate FSC now. This FSC we have to calculate for Xu max because now we have mu limit over here. So using epsilon SC formula, we will put this as Xu max. And that Xu max we have 0.48 into 550. This is our value of D. And substituting these values, we will get 0.00284. Now for this 0.00284, we have to calculate value of FSC. Now we will put it. So now strengths we know because this is 284. So it is between 0.00276 and 0.00380. And then our value will be in between these two. So by interpolation, we will get this value 351.8 plus 360.9 minus 351.8 divided by difference of these two 0.00380 minus 0.00276 and into this 0.00284 minus this because basic our first value we will have taken this value and from this we are going to get value of FSC. This is 352.5 Newton per mm square. And then by using the formula just I have mentioned over here that MF2 is equal to FSC AC into D minus DC. This is actually DC. And then we will have ASC as MF2 upon FSC into D minus DC. And from this, we are going to get that value that is of ASC, which is equal to 302.3 mm square. And now we have to provide AST for this. And for this one, we can go bars. That is, if we will go bar of 110, no. So we will have 12. So 12 we have 12 mm torque, and the area we have for this, that is 113 mm square. So just check it because we have pi by 4 into 12 square, and then that will be 36 into 3.14. And from this we are going to get, this is 113 mm square, and we will go for 2 bars. So it will be, no, sorry, we have to go for 3 bars. So you can go for 3 bars of 12 torque. You can go 16. So for 16 we have 201, and for that value will be around 404. Here 113 into 3, and you will have 339. So we should be economical. If we will go for 16, that goes to 202, which is much greater than this. So we are going to be a doubly reinforced section. So if I will plot this, always whenever you have problem of design, you have to show the number of bars, and that will complete your design. So we will have 3 bars here. So 1, 2, 3, and these 3 bars we have 12 torque. And below we have, that is 1874. So we have, that will be 20 mm, and that number of bars we have calculated, these are 6 bars. So just I will show it properly. Always whenever you will go, you always show it properly. It should not be haphazards. So now student when show it, so it is not in proper way. So we will have 1, 2, 3, 4, 5, and 6. So we have these 6 bars. So 6 bars of 20 torque. So 6 bars of 20 torque. Now we have this as 600 mm. And B we have 300 mm. You show all things properly, and then this both covers we have 50 millimeters. And so likewise we have to show the cross section at the end. So we will stop here only. So this is about your doubly reinforced section, and we will stop here only. Thank you.